This is chapter 1, lesson 5, graph proportional relationships. And in this lesson, we are going to learn how to graph proportional relationships as what we learned in chapter 4 in terms of what proportional relationships are. So we go back to the essential question, how can you show that two objects are proportional? So far we have determined, okay, that two objects are proportional if they have a constant ratio or a constant unit rate. We will be using that definition for us to understand how to, this time in this lesson, graph proportional relationships. So we know what proportional means. It means having a constant ratio or a unit rate. Okay, and in this lesson, we are going to talk about these terms. Okay, a coordinate plane, quadrants, ordered pair, x coordinate, y coordinate, y axis, the origin, and the x axis. Okay, so let's move on right away to our vocabulary startup. Okay, maps have grids to locate cities. Okay, so the coordinate plane is a type of grid that is formed when two number lines intersect at their 0 points. Okay, the number lines separate the coordinate plane into four regions called the quadrants. So the coordinate plane, let me just give me a short background of what the coordinate plane is. When your car's GPS, for example, finds a location on the map, okay, it basically uses a coordinate plane. And this coordinate plane is found by satellites orbiting space. So the coordinate plane is is the very foundation of how the GPS or the global positioning system works. Okay, so let's take a look at this one. Defines what a coordinate plane is. Again, it is a type of grid that is formed when two number lines intersect at their 0 points. Okay, and we can actually separate our coordinate plane into four regions called quadrants. Okay, so the next thing we're going to do is we're going to understand what an ordered pair is. Okay, so for in coordinate planes, okay, there's what we call an ordered pair. So what is an ordered pair? Okay, so an ordered pair is a pair of numbers such as 1, comma 2 used to locate or graph points on the coordinate plane. So yeah, your ordered pair is actually located in your coordinate plane. Okay, the 1, 2, for example, you read this as 1, 2. Okay, the 1, 2 is called the x coordinate. Okay, corresponds to the number on the x axis, and the 2 is your y coordinate, corresponds to a number on the y axis. So let's take a look at this one right here. This is your coordinate plane. Okay, remember the definition, type of grid that forms when two number lines intersect at their 0 points. So these are your two number lines, a vertical number line and a horizontal number line. They intersect at the 0 points. And it's divided into four quadrants. Quadrant 1, right here, quadrant 2, quadrant 3, and quadrant 4. And we also defined 1, 2 as our ordered pair. So we can actually write this as we label our coordinate plane. So this is our ordered pair. Write this down in your book as you go along with me. Okay. And 1 we know for a fact is our x coordinate. Okay, from here. Okay, and 2 is our y coordinate. Okay, now let's label other things in our coordinate plane. So this right here, the vertical number line is called, okay, our y-axis. See here, the vertical number line again is our y-axis. The horizontal number line, this one right here, is called our x-axis. Okay, so that's the reason why you have an x there. That's our horizontal number line. And where they intersect, right at this point, okay, is called our origin. Okay, so those are some definitions that you need to know about coordinate plane. So we're able to define coordinate plane, quadrants, ordered pair, x and y coordinates, the axes, x and y, and the origin. So let's take a look at this one right here. Okay, graph points to 3 and -3, -2 above. So what we want to do is graph 2, 3. Again, when you do this, remember this is an ordered pair. So that means this is your x coordinate and that's your y coordinate. What does that mean? I am going to go to my x-axis and I'm going to go to 2 right there. So 0, 1, 2 right there. And I'm going to go to y3. 1, 2, 3. So the ordered pair 2, 3 is right here. Okay? Let's take a look at this one right here. -3, -2. Again, this is my x coordinate and this is my y coordinate. We always read the x coordinate first. That's the reason why it's called an ordered pair, because the order you read it is always xy. Okay? So we go to -3, 1, 2, 3. That's -3. And we go down to -2, 1, 2. So this is -3 and -2. Okay? So now it says here, connect the 3 points on a coordinate plane, describe the graph. Now, if I connect it with a, let's say, a red line, those 3 points right there, okay, you notice that those 3 points actually form a straight line. So you put arrowheads, arrowheads, those 3 points actually, when you connect them, form a straight line. Okay? All right, let's move on. Identifying proportional relationships. So in identifying proportional relationships, okay, uh, we need to look at to determine uh, another way to determine whether two quantities are proportional is to graph the quantities on a coordinate plane. Okay, and this is what you need to take note of. If the graph of the two quantities is a straight line through the origin, then the two quantities are proportional. Okay, there are two things to remember here. If the graph of the two quantities is a straight line, so that's the one thing that you need, first thing that you need to remember, and that straight line goes through the origin, okay, then the two quantities are proportional. Okay, and if you look at this example again, what we did here, okay, you notice that you have a straight line. It does not go through the origin, so this particular graph right here is not proportional. Okay, so again, for it to be proportional, it has to be a straight line and it has to go through the origin. Okay, those two things need to be in place for two quantities to be proportional. Let's take a look at example number 1. The slowest mammal on Earth is the tree sloth. It moves at a speed of 6 feet per minute. Determine whether the number of feet the sloth moves is proportional to the number of minutes it moves by graphing on the coordinate plane. So you are going to look at two quantities here. Okay, the number of feet the sloth moves. So the number of feet is the first quantity, and the number of minutes is the second quantity. So your two quantities that you're being asked to determine if they're proportional or not will be the number of feet it moves, okay, to the number of minutes. And it says here by graphing it on the coordinate plane. So let's take a look at step number one. First, for step number one, we need to create a table. So make a table to find the number of feet walked for 0, 1, 2, 3, and 4 minutes. So to create that table, this is how the table will look like. On the top part will be the time or the minutes right here, number of minutes. And the bottom part will be the distance in feet or the number of feet right here. Okay. And if we analyze our table, in 0 minutes, obviously the sloth didn't move uh, uh, anywhere, so it travels at 0 distance. In 1 minute, the sloth moves 6 feet because of this fact right here. Okay, 6 feet per minute. That's where it gets it from. So from there, we can actually create more in the table in 2 minutes, 12 feet, 3 minutes, 18 feet, and in 4 minutes, okay, the sloth moves 24 feet. So we have created our table, okay? And if you take a look at the step number two, after that, we are simply going to first graph the ordered pairs, time, distance on the coordinate plane, then connect the ordered pairs. So if you take a look at our table right here, before we graph it, you need to understand that time is on our x-axis, okay? So time is our x-axis right here, should be on our x-axis, and distance should be on our y-axis, okay? So if we do that, this is how it's going to come out. Distance, okay, y-axis, time, x-axis right here. So distance is our y-axis, time is on our x-axis. Okay, now how did those points come about? Let's take a look at a closer look. 0, 0 is right here. 1, 6, 1, and 6 right here. This is 212, ordered pair 212. This is ordered pair 318, and this is ordered pair 424. And if you notice, it forms a straight line that passes through the origin. So this is our origin. Remember, origin has an ordered pair of 0, 0. Okay, so it passes through our origin. So what does that mean? According to our definition, if it's a straight line, it passes through the origin. Okay, so the number of feet traveled is proportional to the number of minutes. Okay, all right. Do the got it problem. Okay, follow the same steps, and let's see if you understand it. Let's take a look at example number two. Now, in example number two, it's asking for the cost of renting video games from Games Inc. is shown at the table. So let's take a look at our table. Cost of renting video games. If you rent one game, the cost is $3. If you rent two games, the cost is $5. If you rent three games, the cost is $7. And if you rent four games, the cost is $9. Okay? So first and foremost, we're going to use that table and we're going to write two quantities as ordered pairs, okay? Number of games against cost. So basically, this will become our, okay, x-axis, and this will become our y-axis, right there, okay? And that's exactly what we're going to be doing. We are going to write them as two or quantities ordered pairs, number of games cost, number of games, and the cost. The number of games, okay, will be our x, and the cost will be our y. Okay, so if we are going to do that, the ordered pairs therefore after doing that will be 1 3, okay, 1 3 from here, 1 3, 2 5 from here, 2 5, 3 7 from here, and 4 9 from there. So after we have created our ordered pairs, okay, the next thing we need to do is we are going to graph the ordered pairs on a coordinate plane, then connect the ordered pairs and extend the line to the y-axis. So again, remember that our x-axis will be the number of games and our y-axis will be the cost, so that when you look at the graph, it makes more sense. So if you look at the graph right here, the cost will be our y-axis and our x will be the number of games. And if we plot all of those, okay, again, we'll put red. And if I plot them, 1, 3 is here, okay, 2, 5 is here, 3, 7 is here, 4, 9, sorry, 1, 3, let me redo that again. Okay, 1, 3 is here, I'm sorry, right there. 2, 5 is here, 3, 7 is here, 4, 9 is here. Now you notice if I connect the dots, it will form a straight line, but the problem is it will not, okay, it will not go through the origin. Remember, this is our origin right here. This is our origin. It does not go through our origin. If I extend that line, that blue line right here, it's not going to go through our origin. Okay? So you notice it does not go through our origin. What does that mean? If it does not go through our origin, that means it's not proportional. So the line does not pass through the origin, so the cost of the video games is not proportional to the number of games rented. Now, if you go back to the definition of proportional relationships, remember they have to be a constant ratio. And if you look at the ratios here, 1/3 is not equal to 2/5. So again, by definition alone, okay, it is not, this is not, okay, a proportional relationship. Okay? All right, do the got it and see if you understand that particular example. Last example, of course, will always be a word problem. So in example number 3, okay, uh, we talk about baseball. So in this case, it's saying which batting cage represents a proportional relationship between the number of pitches thrown and the cost. So you have this graph right here. This is the batting cage for Softball Plus. That's the name of the batting cage. And this is for Fun Center. So again, it's asking which batting cage represents a proportional relationship between the number of pitches, which is our X, and the number and the cost. So the number of pitches thrown, which is our X, and the cost. Okay. So if you notice, this is Softball Plus. It is a straight line, but it does not go through the origin. Fun Center, on the other hand, is also a straight line, but goes through the origin. So in this case, okay, the graph for Softball Plus is a straight line, but does not pass through the origin. So the relationship for Softball Plus is not proportional. On the other hand, if you look at the Fun Center, it is a straight line that goes through the origin. So the relationship between the number of pitches thrown and the cost is proportional. So the answer, of course, would be Fun Center, okay, where the number of pitches thrown and the cost is proportional, okay? And that's the end of our lesson. Thank you for